Hi guys, the next part of our topic we'll be looking at amines. It's a very short part. There's not too many reactions or anything like that, so we should be able to cover it in a short amount of time, just kind of one day. So here's what you'll be learning. You should be able to name and draw amines. You should be able to identify them as bases and explain the properties resulting from that, and then identify products of the reactions of amines. So first things first, an amine has its functional group is an N to H, okay? And depending on how many carbons it has bonded to that nitrogen, will depend on how many H's there are. So what we see here is a primary amine because the nitrogen only has one carbon bonded to it. Here is a secondary amine. It has two carbons bonded to it, therefore it only has one hydrogen. And then here is a tertiary amine, three carbons bonded to that nitrogen, therefore it has no hydrogen. We actually only really deal with primary amines at level 3. You will not be asked to name or draw secondary or tertiary amines. The only possibility is if there was a reaction scheme question where you have to sort of do step 1, step 2, step 3, and step 3, let's say, includes formation of an amine. You may have to draw the product for a secondary or tertiary, but you would not have to name it. So naming them, all we do is, if we go back to the original example, for instance, methane, we remove the E from methane and we put amine at the end. So this is one carbon long, therefore it's methanamine. Okay, let's go to your SciPad for an example, another example. Let's go down to question A. We've got 1, 2, 3 carbons in the longest chain, therefore it is propanamine. Propanamine. Okay, we still have the same rules as branches as previously. 1, 2, 3, 4 carbons, so that's going to be butanamine. But of course, we've got this chloro part we need to name. Because the amine part is attached to this carbon, this must be carbon number 1. Therefore, that's carbon number 2. So we call this one 2-chlorobutanamine. Okay, so I won't get you to name ones like this one here, E, or even F, because those are, and G and H and I, because those are all secondary and tertiary amines, which you don't need to be able to name. Okay, so let's look at the reactions of amines. So first thing is we have covered this reaction already in the haloalkane section, which was at the end of last term while we were at school. And this is how you form amines. So you can get a haloalkane. Okay, in this example, we've got 2-bromopropane. You can add ammonia in aqueous solutions. This is aqueous ammonia, and it's going to form an amine and then an ammonium ion. So in this case, ammonium bromide. There are other ways you could react ammonia in alcoholic solutions. So if we were to change this to alcoholic, it would form an amine, but it changes the product over here. Okay, so the standard one is aqueous. I think in your SciPad it shows the example of alcoholic, but both are fine. Okay, so that's pretty simple in terms of how to form them. We've covered it before. Let's look at the reactions of amines. So first things first is that amines are bases. Okay, just like our normal term with acids and bases, they act like bases, well, they are bases. So what this means is that they will do simple reactions that you've covered previously in year 11. For instance, neutralization. Okay, amines are going to neutralize any acid, okay, because they are bases. They'll also do simple things like turn red litmus paper blue, okay, and that's quite an important identification that they are bases because it comes into the exam questions quite a lot. While it's a very simple concept, it comes into bigger questions, which I'll show you in a moment. Next thing, so reactions of them. The main reactions that we cover, other than the formation as we see here with haloalkanes, the main reaction that we see is their reactions as bases. So from year 12, you'll know about acids and bases being proton donors and proton acceptors. So if amines are bases, they accept protons from acids. So when amine reacts with water, okay, here's our water molecule, here's our amine. Water is acting as an acid in this situation. It's going to donate a proton being an H+ ion. It's going to donate an H+ to this amine. So have a look here. We're going to skip actually to step 3. What's happened is the water, which is H2O, has donated an H+. You can see this nitrogen now has 3 hydrogens attached to it. Before it only had 2, and it becomes a plus. So this is an ion. Okay, this is an ethyl ammonium ion. Ethyl because of this, and it's ammonium, which is what happens when you form NH3 ammonia to NH4 ammonium. So, and then of course what's left over is our OH minus, and that's what gives it its basic properties, because when an amine reacts with water, it forms OH minus ions. It forms a basic solution. Okay, so that's the most common reaction, is just with water, and each time it's really simple. It's just accepting a proton from the H2O. Okay, let's go back and look at the properties of amines. So they have a characteristic fishy smell. So off fish, and fish that's a little bit old, it's not really fresh, has a really strong sort of fishy smell to it, and that's actually because fish produce when it decomposes and becomes a bit older, it produces amines. They have high melting and boiling points compared with alkanes, and this is due to their strong intermolecular bonds. Now, hydrogen bonding is something we're going to learn in the 3.4 topic, the external topic later. You don't need to worry about what hydrogen bonding is at this point. All you need to be able to recognize is that they have high melting and boiling points because they have strong intermolecular forces. Okay, their solubility, we've covered this trend lots last term. They are going to be very soluble when they are short chain molecules. So for instance, this nitrogen to hydrogen bond is very electronegative, therefore it's going to make this molecule polar, very polar, therefore it's going to dissolve in water. If, however, we added a carbon, 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 this whole part here is non-polar. Okay, this carbon chain is non-polar, and this little tiny bit at the end here is the polar part. So the longer the chain becomes, the less significant this polar end becomes. So the longer the chain, the less polar the whole molecule is. Therefore, relate that to solubility. The longer the carbon chain, the less soluble they're going to be. And that's the same for alcohols. It's the same for haloalkanes as well as aldehydes and ketones. So it's the same principle there. Okay, what I want us to do is quickly look at an exam question just to show you how the properties of amines, particularly around them being bases, comes into play. So let's have a look here. So this question is from 2016 exam. It's question 2. Question 2b. You're asked just simply to name structures A to D. That's not what we're going to be focused on. You'd need to name this one, which is our amine. This one down here is an aldehyde. This is an acyl chloride, which we haven't done yet. This one's a ketone. So we're focusing on this. So naming this would be propanamine. Okay, the next part, which is the part I want us to focus on, is it says, explain how you would identify each of the organic substances, A to D, so these ones from up here, from the table using only moist litmus paper, water, and Benedict's solution. So you have to use litmus paper, water, and Benedict's solution to react with these and identify which one's which. So the first thing is your moist litmus paper. Okay, because amines are simply bases, if you add moist red litmus paper to this, it's going to turn blue. This is not a base, this is not a base, this is not a base. So while you're not going to be asked a question, what happens when you put moist litmus paper with an amine? That's way too simple. You could be asked in this sort of format, more problem solving and with other content involved. Okay, guys, I'm going to get you to practice some work in the SciPad, but otherwise this is a pretty small topic, and I'll be setting you some more work tomorrow. What I'm a little bit worried about is I haven't had many people ask me questions at all. Very few emails or messages, and not many people dropping into the Google Meet video sessions. So that tells me that either people are fine with everything and understanding everything, or we're too shy and not being proactive about it, or perhaps we're not doing the work as much as we could. We're going to be in this thing for quite a long time, for quite a few more weeks, so we really need to be proactive about asking questions. So please make it a goal for this week is to ask me a question. All right, thank you. Bye.